You're listening to WCAT Radio, your home for authentic Catholic programming.
Welcome, everyone, to an ITEST webinar entitled A New Understanding of Quantum Mechanics Back to Aristotle and Aquinas. Our presenters today are going to be Dr. Sebastian Mahfood, Kenneth Francis, and Dr. Robert Kurland. My name is Tom Sheehan. I am the Director Emeritus of ITEST, and I'm currently its Science Advisor. The Institute for Theological Encounter with Science and Technology, that is, ITEST, is an association of theologians, scientists, and others committed to a Catholic worldview in which faith and science collaborate in exploring the truth. ITEST explores truth theologically in the wisdom tradition of the human community and in the data studied in the sciences. ITEST's mission is to foster and disseminate the Catholic position that science and faith in God are compatible and are complementary paths to human fulfillment. Before I introduce our first presenter, Father Michael Lampe will offer our opening prayer. Father Lampe is a priest to the Archdiocese of St. Louis and pastor of historic Immaculate Conception Parish in Old Monroe, Missouri. Listen to his homilies sometime and reflection as Father Lampe's podcast, which is available. So, Father Lampe, it's yours.
In the name of the Father, and of the Son, and of the Holy Spirit, amen. Heavenly Father, we ask you to be with us during this webinar, to open our hearts and minds to all the ways that you would like us to go deeper into the mysteries of your creation and the relationship between science and faith. Help us to go deeper and help us to also grow in faith, hope, and charity in the midst of this conversation. We ask all of this through Christ our Lord. Amen.
Well, thank you, Father Lampe. Our first presenter today is Dr. Sebastian Mahfood, OP. He is a lay Dominican of the province of St. Albert the Great. Sebastian has been a Catholic seminary and college professor and administrator for over 2 decades. Dr. Mahfood is now president of En route Books and Media, as well as WCAT Radio, and he serves as director of ITEST. Dr. Mahfood's presentation today is entitled Introduction to Aristotelian-Thomistic Metaphysics.
Well, thank you very much, Tom. And welcome, everybody. We have a 3-part webinar today that includes a very short bit by me, a longer bit by Ken Francis, and a much longer bit by Bob Kurland, who is the star of our show. A short romp from Aristotelian-Thomistic metaphysics into quantum mechanics. So the presentation will begin with an understanding of metaphysics as one of 3 levels of abstraction. So in the Aristotelian Thomistic world, you have the study of the physical world, we'll call that physics. You have the study of the mathematical world, we'll call that quantitative being. And then we have study of the non-material world, or the non-physical world, and we'll call that metaphysics. So these 3 levels of abstraction then have meaning for us. You know, we would say, okay, material being is what we can see, what we can perceive with our senses, what has matter and has a physical substance. And non-material being would be that in a Thomistic understanding of what is spiritual. So we can see non-material being, for instance, in things like God or the human soul. And we would say the soul is the form of the body. So there's a relationship between the non-material being or the spiritual being and the material being. And on the second level of abstraction would be quantifiable being. For instance, if I were to say here are 2 persons, I've got the number 2, quantity. It's a quantifiable reality rather than a physical reality. Now, Aristotle began his metaphysics by saying that all men desire to know, as is evidenced by the delight they take in their senses. So immediately in the start of his metaphysics, he jumps into epistemology, into a theory of knowledge. And, how do we understand what something is? What the relationship between things are? Is there a relationship between the third level of abstraction, let's say spiritual being or God, if we were to shift into theology, and the first level of abstraction, that is physical being? So there's the relationship between our creator and the thing created. St. Thomas would say, sure, there is a relationship there. So Aristotle's process was threefold. He would focus on a study, and then he would zoom in on the thing being studied, whatever that being was, and then he would hone in on the manner in which the thing is studied. So in the first level of abstraction, you would focus on being qua movable, that is, being in the sense that it is a movable being. In the second level, he would focus on being qua measurable, that is, being in as much as it is able to be measured. And then being qua being in as much as it is a being, is the third level. So in the Aristotelian-Thomistic world, physics is qualitative. It relies on observation. It relies on categorization of natural phenomena. It's not a quantitative thing. To learn, we apply our senses to the world, and we perceive that world in relation to ourselves. And this creates a phantasm. And phantasms are images similar to sensation, but they're immaterial. They're needed for the activity of the intellect. So I only have to touch a hot stove once to get the concept of hotness. So my percept, my sensory perception, gets converted into a concept, into a universal concept. Now, we know that sensory perceptions can be distorted. You are looking at something approaching you, and you say, this is so-and-so, I know him by his gait. But maybe there are two people with the same gait. So as the object gets closer and closer, you realize it's not the thing that you thought you knew. And so you modify, you adjust. But there are some things that, depend relative to the degree at which something is hot to you as opposed to hot to somebody else, where your sensory perception can be somewhat reliable. And it's something we like to explore in the way in which we desire to know things. But we're going to do it in a qualitative way, relying on observation and categorization of natural phenomena in Aristotelian-Thomistic shift, and trying to understand God as the cause of things. God knows things as their cause. We know things in their effects. And it's those effects, those percepts, those experiences we have, those things that we come to know through our study of the physical world, that enables us to have some sense of the cause of those physical processes or that physical world. And that's the relationship between the third and first levels of abstraction. But something happens when Isaac Newton shows up. He creates a classical mechanics that is quantitative. That is, instead of an Aristotelian physics, which is qualitative, we find ourselves in a physics system that studies motion relative to forces, with an emphasis on experimentation and mathematical equations. So we're bringing together the first and second levels of abstraction in our trying to understand the natural world, and in our trying to understand the relationship between that natural world and the cause of that natural world. So if we were to shift from an Aristotelian Thomistic understanding of physics into a Newtonian understanding of physics, that has some impact or some effect on our study of being, in as much as it's being. So does our metaphysics need to shift as our science shifts? Would be a question you might want to ask. And Newtonian classical mechanics focuses on things like forces and has underlying metaphysical assumptions that these forces are real. Gravity, weak force, electromagnetic force, and strong nuclear force. Another underlying metaphysical assumption would be that inertial mass is primitive or fundamental. The measurement inertial mass would be the measurement of an object's resistance to acceleration. So in an Aristotelian world, objects that move simply return to their point of rest. In a Newtonian world, there's resistance and acceleration that occur, and an object in motion will stay in motion until acted upon by some outside force. In another underlying metaphysical assumption in a Newtonian world is that space is substantival. It has a separate and independent existence. Shifting then, leaping to Planck's quantum mechanics. Quantum mechanics studies the behavior of matter and energy at the molecular, atomic, nuclear, and even smaller microscopic levels. So it's not really things that we can observe. Remember, the delight we take in our senses in an Aristotelian world would have been senses such as sight, which he says is the best of all senses, hearing, taste, touch, and smell. In a Newtonian world, we're increasingly applying extensions of our senses, which Marshall McLuhan would call our technologies. A technology is simply an extension of the sense. So my eyeglasses are an extension of my ability to see, and it is an artificial amplification of those senses that I'm applying to the world in a Newtonian world, but even more so in a quantum world, because I can't see matter and energy at the molecular, atomic, nuclear, and even smaller microscopic levels with my natural eyes. So we have an artificial amplification that's being applied. McLuhan also provided a caveat. He said every artificial amplification of the human person brings about a natural amputation. So when I take off my glasses, I can't see nearly as well as before I adjusted my eyes to the concept of better vision through the glasses. So in a quantum world, measurement brings into being the measured property as opposed to revealing it. So, I mean, you've got experiments where you're looking at light as a particle in a wave, and it's the observer that brings that property into being, as opposed to the observer who simply reveals that property. There is a complementarity between dynamic or changing and kinematic, which deals with the relationship of variables of motion to one another, aspects of the world. And all properties of atoms are irreducibly relative to a measuring apparatus. So these 3 points here are metaphysical assumptions of quantum mechanics in the same way that these 3 points are metaphysical assumptions of Newtonian classical mechanics. So the more we engage in our understanding of the material or physical world, the more that study of the first level of abstraction, the physical world, the material world, has the possibility of challenging and even honing our metaphysical understanding. That is, our understanding of God as cause, as opposed to simply our understanding of things in their effects. It's possible that the more engaged we are in studying the natural world, in whatever methods that we use, whatever manners in which we're studying, we can grow and develop greater insight into our understanding of God, who is the creator of all of it. And this is a fundamental point that ITEST advances, that our study of nature enables a greater understanding of nature's creator.
Okay, thank you very much, Sebastian, for your presentation. Now I'm pleased to introduce our next presenter, who is Kenneth Francis. He's a freelance journalist and contributing editor at New English Review. For the past 30 years, he has worked as an editor in various publications and print media, as well as a university professor in journalism. He holds an MA in theology, and he is the author of several books. One is The Little Book of God, Mind, Cosmos, and Truth, from St. Paul's Publishing. Another is The Terror of Existence, From Ecclesiastes to Theater of the Absurd. That's with Theodore Dalrymple. Another book is Neither Trumpets Nor Violins with Theodore Dalrymple and Samuel Hooks. Kenneth resides in Dublin, Ireland. Kenneth Francis' presentation is entitled God and Quantum Theory.
So it's interesting what Sebastian was saying there, which is parallel to what I'm going to talk about to a certain degree. And this whole idea of perception, consciousness, and the aspect of appearance and reality, which Bertrand Russell wrote about very eloquently, although I am not a fan of Russell. And it's very interesting to note that things we see around us are perceived from a favorable point of view. And one example would be maybe a fingerprint, a human fingerprint, which looks like a little kind of, pattern of squiggles when it's looked upon. And then when looked upon through a microscope, it looks like the Himalayas. And when viewed from maybe 20 feet away on a wall, it looks like a spot. So the question is, what does a fingerprint look like? What does a shed look like? A table look like? A chair? The ocean? All these things are viewed from a certain point of view, a certain distance. But to understand what they really look like is quite tricky. Another example would be a tree. From a distance, it looks like the classical tree from 20 feet away or 10 feet. Close up, with a microscope, it looks like some bizarre rat's nest with all the squiggles in the bark. And we can go on further into inner space and reverse back out into outer space, and it keeps changing. So we tend to perceive it from a favorable point of view, which Russell called favoritism, which is interesting. Which brings me on to the question of God and quantum theory. And I want to really kind of relate a lot of this talk to the aspect of consciousness and God's role in it and the human perception of the world. And a few things here I note about consciousness, and it's a very controversial issue in the literature out there, is that there's this thing about the mind-body problem, the mind-brain problem. And I, from a theistic point of view, don't have a problem with that. But I think secular people do, which I'll come to later to say why. But the reason I don't have a problem is because I believe the mind is separate to the brain in terms of epiphenomenalism, which is brain and mind are the same. I disagree with that. And I'll explain briefly why that cannot be. And here's why. If you open up a person's head, not to be too graphic about it, grotesque, and look at the blurb of matter, that's like a big wet organ, you cannot point to a section and say, oh, look, there's the part where Joel loves Mary, or the part where, Jimmy hates Mary, or whatever. There is no thing in the brain when opened up that will reveal those parts like hate. There's the part where someone hates someone, or the part where someone prefers vanilla ice cream to whatever. But when a mind is put into the equation, then it does make sense. And I always draw the analogy that the mind is a person getting into an automobile, which is the brain, and driving off. And so it's the ghost in the machine. The mind has to interact with the brain to interact with reality, the external world. And if the brain is damaged or the car is damaged, it doesn't function right. But that doesn't mean the mind can't think the right things or will the right thing to happen. And we might see this with brain damaged people. He might be able to think straight, but whilst trying to interact with reality, like make a movement, an arm gesture, they can't, because the car, the brain, to use an analogy, is broken. It doesn't function. And the problem here with quantum mechanics and scientists is that I have a fear it could lead to a kind of Tower of Babel situation, whereby the boundaries of science saw it so fanatical, as we see in places like CERN, that we might have a situation where it could all collapse and crumble, like the Tower of Babel. And we know how all that went, not very good. And it's similar to the Garden of Eden, and where the mother of all errors was human beings tried to be like God. Again, there's a boundary there, and we should kind of step back a little and not seek to have omniscience, which only God can have. God can only be all-knowing. If we try to do that, then it's almost sinful in terms of the God of Christianity. So this is where I see quantum physics being something which very difficult to understand, is out there, exists possibly, but is mysterious. And God is saying, well, I'll let you know so much about it, but back off, don't start building on the Tower of Babel. And so there are only certain things we know. And as you're aware, there's a certain amount of interpretations in quantum mechanics. And they seem to, I don't know, I think it's 10 or 11. I can be corrected on that. And they all seem to have a valid, representation. Each one seems equal to the next. So it's very difficult to select which interpretations is the right one. Anyway, to get back to God and consciousness and quantum physics, the desperation now in the science community among secularists is that they can't cope with this mind-brain problem and consciousness. And they have to, I call this kind of atheist of the gaps, where you say, well, what can we do? We're really stuck on this. So they say panpsychism. Yes, that's where it's at, which I'll come to later. But there's a few other things as well they might grasp at. But panpsychism seems to be gaining a little ground, as though it sounds crazy. For those unaware of the term, it's the concept that everything is conscious, including quarks, electrons, even the microcosm level, things are conscious, maybe to a lesser degree to human beings. But I think if it's true, well then, think of our spare thought for toilet rolls and toilet bowls and even sewer pipes. Maybe they might have rights too, but a case of you'd rather be a hammer than a nail if it's true. I don't think it's true at all. From a Christian perspective, it certainly is not. And you might ask, well, where did this crazy idea come from? It does go back a long time. I think with Spinoza, we had pantheism, which is kind of like panpsychism, where the whole universe, the cosmos, is like a mind, but not an entity like God, which was probably termed, I can be corrected here, as panentheism, very similar sounding word or concept, where there is a separate entity that is God. And another, by the way, in terms of the mind-brain problem being, the most difficult in philosophy, I think from a secularist point of view, that could be true. But from a theistic point of view, I would regard the biggest problem, and it certainly is enormous, would be God's relationship with time and eternity. And if you can think about that, that is some hang-digger of a problem, because it implies that we have an eternal situation, right? With something happens within it which shouldn't, because it's eternal and fixed. But I would put it down to being a mystery that I won't go there. It could be another Tower of Babel kind of concept to try to work out. So no, I leave it as a mystery, as is some other things within Christianity. Another aspect of this would be a very weird, creepy term called solipsism, which I'm sure we're all familiar with on the chat today. And solipsism, you think of things like the Copenhagen interpretation, this about the waves and the particles and the way things could be governed by how the perceiver sees it. There's something very solipsistic about that I find a bit kind of weird. It's almost like a mind, a spirited mind, kind of willing things to do things a certain way. I don't know, maybe we can expand on this later in the Q&A, but it is actually quite strange. And to get back to the consciousness problem again, and panpsychism, is that if we are nothing but just the brain, if the human being is nothing but the brain, it's actually self-refuting, because the brain wouldn't be a self. And let me explain again, and it's probably a crude analogy, or for instance, electrons or quarks, okay, and they possess consciousness, right? That's crazy, because they can't be about something. There's a term called aboutness. But with human beings, there is an aboutness. We are about something. Things we do are about things. But functions that they apply to are not about things. There's no aboutness on it, okay? And there's also, they lack the I. As a person might think, oh, I might suffer because of this. Or, well, if you look at dogs, giraffes, apes, chairs, animals, right? They don't think about possessing the I, an identity. They just are. And, you say, take a bird, for instance, and it's impregnated and it's gone off to build its nest, and it's gathering all these twigs and builds a beautiful, elaborate nest. So the bird is not thinking, oh, we're going to have a family to rear very soon, and I have to get all this house built. It's hardwired. God will be part of this. And in a fallen world, there's a lot of cruelty involved in that hardwiredness, because if you look at birds and the animal kingdom, it's quite nasty. As Schopenhauer said, it's a world of perpetual screaming. But that's because the world has fallen. And prior to that, that would have been the case. But I think that in terms of quantum physics, there's a long way to go, and we should know our boundaries. I think that the worry here is what I would call the CERN effect. And if you're not familiar with CERN, their logo looks like an abstract 3 sixes, which is kind of very strange. The opening ceremony was like something from a satanic movie. I'm sure people have seen it. It's on YouTube. You can go in there. There is a statue of Shiva outside, the goddess of destruction, and a lot of other things that are, and I'm sure there are good folk working at CERN as well. But the mad scientist thing does tend to worry me a little, and what they're pursuing. I also want to talk a little bit about, because this person is actually quite interesting regarding quantum physics. He wouldn't have known much about it, because he was a long time before it emerged. But George Berkeley, who was a philosopher from Ireland, a bishop, and he, as far as I'm concerned, he came really close to defining the universe and the reality of the so-called, for him, external world. And I wrote an essay in New English Review about 7 years ago, you'll find it, called Is the Universe a Hologram? It's Berkeley's universe. And Berkeley would, and again, this is really kind of in a nutshell, because you could talk so much about this and so much complications, but to simplify it, Berkeley thought that nothing can be, everything has to be mind dependent, and the universe is in the mind of God, and we're in a kind of like a community of souls who possess minds as well that God can oversee. So the tree that falls in the forest does make a sound because God hears it. Would be according to Berkeley. So I have a piece here from him, a quote, which is interesting. This comes from the one of his books called Of the Principles of Human Understanding. And he wrote the following, quote, "It is indeed an opinion strangely prevailing among men that houses, mountains, rivers, and the world, all sensible objects, have an existence, natural or real, distinct from their being perceived by the understanding. And then they abbreviate the quote following, again, quote again, for what are the aforementioned objects but the things we perceive by sense? And what do we perceive besides our own ideas or sensations? And is it plainly repugnant that any one of these or any combination of them should exist unperceived? So, end quote. So what Berkeley is more or less saying there is that, things have to only exist through the perception of a mind. God would be the ultimate mind. Now we go back to quantum physics. So the observer observing these strange, weird goings on in the subatomic world, where does that stand in terms of perception? And is it a purely subjective thing to the perceiver, getting back to the Copenhagen interpretation situation, or is there something beyond that? I think we can complicate things a lot and just rely on God and the Bible and things to kind of guide us on how the world works. And you could ask us, well, why would God have inserted such weird things into the universe, like quantum mechanics? Well, maybe, he did it because it would make us interested in the cosmos. He could have made a solar system without any galaxies, which would be quite boring. He could have made just a single Earth. We'd be nothing more than a speck of solar dust orbiting a great ball of fire, which is even more boring. So I think all the wonders of the world that God has created is for our benefit. But he does say, I think, to a degree, back off. And we get back here once again to the Tower of Babel, that to overreach, it's first of all, it's not a Christian thing. It's not a practical thing, even in the secular world. It always, when you overplay your hand, which you can see with lots of people, it ends up in disaster. From a secular point of view, I can think of a movie called The Swimmer with Burt Lancaster, and he overplays his hand in everything in life and ends up, spoiler alert, at the end of his rope. And that would be kind of a materialistic analogy, plus spiritual as well. But just one last thing before I close on this, on the consciousness. Yeah, the core message of my talk here is really the boundaries that I don't think we should actually play around with. This thing about God doesn't play dice in the universe or whatever. And I wonder what CERN have up their sleeve next, because it's the biggest machine in the world. And it's doing things that a lot of people don't understand. And really, that's where I can end that. I know my 20 minutes has expired.
Okay, thank you very much, Ken.
Okay,
Tom, wonderful presentation.
Thank you very much.
Now I'm pleased to introduce our last presenter, Dr. Robert Kurland. He's a convert to Catholicism in 1995. He's a retired physicist who has applied magnetic resonance to problems of biological interest in his research. If you want to know more about that, you can do a web search on the Kurland-McGarvey equation. Okay. Dr. Kurland began to learn about quantum mechanics at Caltech, where he got a BS degree with honor in 1951. At Harvard, a master's in 1953 and a PhD in 1956. From courses taught by Richard Feynman and Julian Schwinger, among others. In teaching quantum mechanics to students at Carnegie Mellon University and SUNY AB, he found that mathematical formalism of quantum mechanics was an obstacle to understanding. So in his talk, he will try to explain what quantum mechanics is about using a minimum of mathematics, as he did in his book entitled Mysteries, Quantum and Theological. So Dr. Kurland's presentation is entitled A New Understanding of Quantum Mechanics Back to Aristotle and Aquinas. Dr. Kurland.
Thank you, Tom, and thank you, Dr. Mahfood and Ken Francis, for setting a good foundation for what I'm going to say. I hope I can live up to your presentations. I'm going to talk about quantum mysteries, and We have several understandings of mysteries. A mystery story, something that a crime that's been committed that you don't know how it's done. I'm a fan of that. The mysteries of the rosary, the mysteries of theology. And by quantum mysteries, I mean behavior that is mathematically explained and predictable, but that goes against our intuition, that doesn't seem to match what we know about physics or how the world behaves. And as Ken Francis said, there are many interpretations. I think I counted 17 in Wikipedia article of how quantum mechanics works. And one way of dealing with this is to say the math works, we don't need to explain it. But that isn't satisfactory. As human beings, we want to know what's going on. Now, I will discuss in this talk three types of mysteries. The fact that particles behave as waves and waves behave as particles. Particles are entities we think of as being localized, having a definite position. Waves, on the other hand, are entities that are spread through space. They aren't localized. And the fact that these can convert one to the other, depending on the type of experiment, is a mystery. It goes against our intuition. The second type of mystery is superposition. This is the what's commonly, and I think you all know about this, the Schrodinger cat thought experiment, in which a cat can be both dead and alive, depending on the what sort of radiation occurs to trigger a cyanide. Now, the third type of mystery is entanglement, that in pairs or groups of particles, their properties are linked together, they're correlated. And this correlation extends through space, and it's instantaneous. It doesn't seem to follow the relativistic principle that communication cannot be sent faster than the speed of light. So one explanation, one interpretation is going back to Aristotelian-Thomistic metaphysics, and I'm certainly not an expert in that. I thank Dr. Mahfood for setting things up, and I'll give my own primitive thoughts on it in the course of this talk. I've talked about these mysteries, not about the Aristotelian-Thomistic interpretation, in a ebook which is available on ITEST, plug, Mysteries, Quantum, and Theological. And the picture at the lower right-hand corner is an illustration of entanglement. They're taken by two groups of photons that are entangled. The one in orange is actually taken a picture of a cat. The one depicted in blue, upside down, the picture was not taken, but it sees what the orange group has taken. And if you look at areas in the pictures, they're identical. They have the same distribution, the same fluctuations, and so forth. Okay, now let's go on for a very primitive explanation of these mysteries. And I apologize to those of you who have seen this before and those who know something about quantum mechanics. I was told some 65, 66 years ago when I began to teach that you teach to the bottom. I'm not saying that the audience here is the bottom, but that you try to explain things, and those who know what you're talking about and already know it will feel flattered, that they will feel good that they have got it, and the ones who don't know will be grateful that you're trying to reach them. Okay, so the first thing is to say a little bit about wave behavior. And a wave is a periodic disturbance. It has a wave velocity. For light, that velocity is denoted as c, the speed of light. And the displacements follow a sine pattern. The difference between corresponding disturbances is the wavelength, lambda. And so you see this, there's a traveling wave, you see it going forth. There's a picture of a bee fluttering its wings and sending waves through water. The high points are showing white and the low points dark. And here is a picture of an electromagnetic wave. The red lines are displacements of the electric vector, and at right angles, the magnetic field are the corresponding displacement, and it travels with the speed of light. And here's just a short survey on what kind of waves you can get from electromagnetic radiation, all the way from very long wavelengths with radio waves, where the wavelengths are the order of buildings, down to very short wavelengths of the order of the dimensions of atomic nuclei, gamma rays. And corresponding to this wavelength or frequency is inverse to the number of times the maxima occurs in a second. The frequency is inverse to wavelength. You'll see at an object that has in thermal equilibrium a corresponding temperature. So for radio waves, that temperature is very low, and microwaves, it's almost down to absolute zero. For visible light wavelength, you'll see temperature corresponding to that for the sun, which is reasonable. The sun gives out visible radiation. And then for X-rays and gamma rays, you'll see much higher energies. And there are stellar objects that do, in fact, have X-ray emission. And I'm not sure about gamma rays. I don't think so. But anyhow. All right. Now, let's do a little bit of explaining by history. My wife, dear departed wife, said if you want to learn about anything, you learn about its history. And so I have tried to teach quantum mechanics via history. And it starts off with Planck at the end of the 19th century. And physics was all set. They knew everything, except maybe calculating the last decimal place. But there were paradoxes. And one of these paradoxes was the so-called ultraviolet catastrophe, that if you link Maxwell's equations and thermodynamics and predicted what how radiation was emitted by a body at a given temperature, it would go off to infinity as the wavelength got shorter and shorter, i.e. as you approached the ultraviolet. And that didn't occur. So Planck's solution was to quantize energy. And so the result is that energy was transferred in little packets of energy E with a constant, Planck's constant, of course, times the frequency, or h times the speed of light over the wavelength. And you can see illustrations of this behavior of energy distribution in our real life. If you look at a fireplace dying down, the embers will be maybe about 800 degrees Kelvin, and it'll show sort of oranges. If you go to molten steel at a much higher temperature, about 1600 Kelvin, it'll look white hot, which is because of the blue, the shorter wavelength mixed in with the red. Okay, now there's some more history. And this was Einstein in 1905, his famous year when he explained Brownian motion and the photoelectric effect. And this showed that light acts like a particle, which he called a photon. The energy of the photon was Planck's constant times the frequency. A photon will hit a metal. If the energy is sufficient, it will tear the metal away from the atom to nucleus to which it's bound, and you'll see it ejected. If there's excess energy, it will show up in the kinetic energy of the ejected electron, i.e. conservation of energy. And this explained the fact that no matter how intense the radiation was, if it didn't achieve a certain wavelength or a certain frequency, then it would not eject electrons from a metal. So we have a duality beginning to show here, that light acts like a particle, a photon. Now, what about the converse? Can a particle act like waves? In 1924, Count de Broglie, proceeding from relativistic consideration, showed that a particle could act like a wave because you could ascribe to it a wavelength given by Planck's constant over its momentum. And as with all science, this has to be confirmed. Suppositions, hypotheses have to be confirmed experimentally, empirically. And in fact, it was done so by the Davison-Germer experiment, in which electrons were targeted a crystal with a regular structure, and they showed a diffraction pattern. We'll say more about diffraction in a little bit. And you saw the diffraction pattern, and so the particles were behaving like a wave. So we have this duality, this wave-particle duality, that is strange and has to be explained. Now, I'm going to digress a little bit, and I'll talk about Dirac. And he introduced a formalism that is a little bit strange, but it's a lot easier to explain quantum mechanics to people using this formalism than going through a partial differential equations, which is another way of looking at quantum mechanics. So he introduced this so-called vector state formalism. The Wikipedia said 1939. I think it must have been much earlier. It must have been 1931 or so. So you have the quantum state represented as a ket or a bra, and bra is written as a vertical line, and then there's some inside stuff, symbols, parameters that describe the state, and then a little caret that ends it. So that's your ket, and then the conjugate, the sort of opposite, is just the opposite of bra. So you have a bra ket bracket. So any particular quantum state can be represented as some linear combination of the independent states. For example, constant times one basis state 1 plus another constant times the basis state 2. And these numbers, C and D, are positive, negative, or they can even be complex numbers. And their squares, that is, their absolute values squared, gives the probability of measuring either the state 1 or state 2. And doing this with, I've got I'm going to have to move my thing. I'm showing the. Okay, I've got to. Excuse me, just a minute. I'm getting a problem with the. Okay, I've got it. The list of the showing the participants is covering up part of the slide. So here's my example. Let's use a voting, this very artificial, husband-wife voting. The wife votes Republican, red hat, husband votes Democratic, blue hat. And one possible state is both voting Democratic, both voting Republican, wife Democrat, well, husband Republican, or the wife Republican and the husband Democrat. And we've put a number 1/2 here so that the problem, we've said that there's an equal probability for each of these possible events, and the event would be the measurement. All right, another digression, and this is Richard Feynman. My senior year at Caltech, I heard his first lectures when he came there, and it was inspiring. I was auditing the class. I didn't take it for credit. And one of the things he said, this was actually a quote from his graduate course, not the one that he gave to the undergraduates. What I'm going to tell you about quantum electrodynamics is what we teach our physics students. It is my task to convince you not to turn away because you don't understand it. You see, my physics students don't understand it. That is because I don't understand it. Nobody does. And this is from somebody who won the Nobel Prize for his explanation of quantum electrodynamics. In other words, this is a testimony to the fact that it is a mystery. There's another quote which is more or less apocryphal. I can't really trace its whether it's truly from him, but supposedly said that if somebody tells you that he understands quantum mechanics, then he's either a liar or a fool. So I don't understand quantum mechanics. Okay. All right. Now here's an illustration of this of how this quantum mystery, the wave-particle duality works, the double slit experiment. The phenomenon is diffraction. Wavefront goes through a small hole or slit or bends, as in the lower left-hand corner. The green lines are in the peaks, and the black lines are the depths. Now, if you have two slits, the wavefront going through one slit can add or subtract to a wavefront going through another slit, and you'll get interference, as shown here. The light blue is a 0, and the yellow is a maximum. Now, particles will indeed act like waves going through a slit and give this diffraction pattern with interference. If you go to classical physics, you would see this is the right-hand corner bottom thing here. You would see them more or less as two columns on two lines on a screen with some scatter. But if you did quantum physics and the particles went through, they would show a diffraction pattern. Now, what I want to say is that each particle will land at a definite spot on the screen. And it's only when you see them all go through that you'll see this diffraction pattern. So particle 1 might go to the top. Particle 2 might go to the middle, particle 3 to the bottom, and so forth. Now, here comes one experiment in which you're talking about the role of the observer and whether consciousness plays a part. If you try to observe which slit a particle goes through by, say, putting a measuring apparatus between the slit and the observing screen, the particles, the wave-like behavior will be removed. Now, the great American physicist who has had many, many clever ideas thought of this delayed choice experiment. He thought of it in an astronomical context where he used a galaxy as a gravitational lens to sort of diverge radiation into two parts. You can use an optical lens to do this, and the idea is to move your recording screen, this is the illustration at the bottom, to move it far enough or remove it, and then use telescopes very far away so that the two beams from the converging lens had diverged so that they no longer overlap, and use two telescopes to observe them. And if you do this, and you do this after the particles have gone through the lens, in other words, you time this removal, you'll find out that the screen has been removed, and they'll behave as particles. So they know in some sense or another that you've done this. And this is a mystery. This is a strange thing. All right. Well, before we go on and tangle with that some more, we'll talk about entanglement. The pairs of particles are produced with linked properties. The properties remain linked even after the particles are separated by long distance. Ordinarily, people use physics quantity, spin, polarization. That isn't intuitive. I'm going to again use this unreal example. And so we're going to assume a happy marriage that the couples vote alike. So our system before measurement is either both husband and wife vote Republican or husband and wife vote Democratic. After voting, which is the measurement, we'll have only a single pair. Now, suppose a husband and wife are separated. Then this coupling, this correlation will exist no matter how far apart they are separated. And there will be no necessity for communication between them. In other words, it will occur if the wife is in Los Angeles and the husband is in New York, or the wife is in Los Angeles and the husband is in Los Angeles and the wife is in a spaceship orbiting the Earth. Now, this is strange, and it happens without any communication, no electromagnetic radiation or anything. And Einstein was very unhappy with this. He called it spooky action at a distance. You know, how can this happen? How can this be? Now, the Irish physicist, one of your people, Ken, made one of the most profound contributions to physics in the 20th century. I like this quote from him. "I am a quantum engineer, but on Sundays I have principles." So he, along with Einstein, thought this was not a good thing for physics to have this spooky action at a distance. So one way to explain this is to assume there are hidden variables that interact locally or by forces transmitted at light speed. And he worked out a theorem on what the correlations would be for separated particles from an entangled pair. And it's a fairly simple, in my book, I give references to simple ways of deriving the theorem, but very fundamental. Now, again, as with all science, you have to do the experiment. You have to verify things empirically. And Clauser and Aspect, French physicists, showed that Bell's theorem was violated. So there's three possible conclusions. That reality, that is what is real, is non-local. There's spooky action at a distance, faster than light. Conclusion two, there's some other kind of reality, the so-called veiled reality that the French philosopher physicist Descartes supposes. Or conclusion three, the experimenter doesn't have free will to choose. It's a super determinism. And Aspect, Clauser, and Zellinger, who was another worker at this, received the Nobel Prize in 2022 for this work disproving Bell's theorem. Here's a rough diagram showing it, the source, the detectors, the splitting beams. For some reason, physicists always call separated things Bob and Alice. I guess there was a movie, Bob and Alice or something, but anyhow. All right, now let's go to theology and quantum theory and how they possibly might intersect. And this is from Clayton's article in one of the CTNS books, the conferences called by St. John Paul II, tracing the lines. Whoops, I got to go back. The first is that you can't give any reason for any theoretical, that it's irrelevant. They are two separate domains. And you can talk about the theological positions, but the quantum mechanics is really too fuzzy to be helpful. The British physicist Polkinghorne takes this position, and he's also an Anglican priest. That you can infer some theology, but it's still speculative. I should mention for Ken Francis that Raymond Chow did an interpretation of the double slit experiment and invoked Berkeley, to be perceived is to exist. So there was a relation there. And then you can say that the physics tells you about theology. And there's a fifth interpretation that the Asian religious traditions and quantum mechanics converge and that they're really one thing. I don't hold very much with that, but that's a prejudice. And finally, the thing that I'll talk about finally is that the Aristotelian, and that's misspelled Aristotelian, but Thomistic philosophy explains quantum mysteries. And there are a whole host of authors who are latched onto this in the last 10, 20 years, and I'll give some references. All right, now let me give you my own ideas about Aristotelian metaphysics, i.e. metaphysics for dummies, me, and if I speak with a physics accent, I hope the philosophers here and theologians will forgive me. So we have these terms, substance, form, and accidents. And an example, and I like to make examples that makes things clear. An ice cube melts when heated and becomes liquid water. So there's a substance, water, an ice cube, frozen water remains the same. When an agent, heat, changes it to liquid, its properties, that is, its accidents, change on this transformation, shape, hardness, solidity. So here's a picture. Here's a neat diagram taken from YouTube of how this is interpreted on a molecular dynamic level. And you start off with ice with the water molecules, protons white, oxygen red. And now it's melting and they're separating. They're still together and interacting by hydrogen bonds. And they're gradually getting more and more energetic as you put more and more heat into it. And they're getting more and more energetic and jumping around more and more. And finally, boom, you heat and they get further apart and they're single. They aren't mixed. They're a steam. They're a gas. So that's the picture on a molecular level of what happens. And it's a nice picture and it's probably pretty accurate. So here are some more terms. Actus, the state of being, potentia, the possibility of existence. The water is in a state of being, as an ice cube has a potentia of being liquid if a suitable transformation agent, heat, is applied. Now, I've looked at a couple different artificial intelligence devices on the web as to whether water and its ice cube are different substances. And I haven't gotten a consistent answer, so I'm not going to answer that question. So, and again, the liquid water has the potentia of being a gas if more heat is applied. Now, the first connection with this Aristotelian notion, ideas of actus and potentia, has to do with the great German physicist Werner Heisenberg. And in his book, Physics and Philosophy, he talks about this. This is one quote, but the world of potentia, and in another quote, he does use the term potentia. There's another philosopher, Wolfgang Smith. He died this year, 94, but did really a monumental piece of work. And his question was, what he enlarged on this, and this is what I'll spend most of the time talking about in the remainder of this talk. And in his book, Quantum Enigma, you have this quote where he mentions potentia. And then there are a series of articles which are here, and I'll comment more. I'll repeat this list later at the end of my talk. All right, now I'll focus first on the view given by Kastner, Kaufman, and Epperson. Kastner is at the University of Maryland. Kaufman I'm not sure where he is now. He was at Los Alamos there, and supposedly he's the model for the genius in the movie about dinosaurs. But I don't know if that's true or not. And that person is in University of California campus. So they use the term KKE. I'll use abbreviate for their authorship. They use the term res potentia and res extensia to describe the nature of a thing. Res extensia is a real thing and can be perceived directly by measurements. Res potentia is also real, but cannot be perceived by sense or instruments. So the act of measurement converts a res potentia to res extensia, as in the double slit experiment, a wave converted to a particle upon measure. And they also use this to explain entanglement. The measurement removes all but one of the entangled states. So that, for example, if you start off with the example I had earlier, both voting Republican or both Democrat, then the measurement, the act of voting, removes one of the states, leaving only either both Republican or both Democrat. Now, Wolfgang Smith proposed a totally, now that I should say that KKE had just this part. They didn't incorporate a total, as I understand it, a total Aristotelian-Thomistic view of a reality or explaining the world. It was just these two ideas of res potentia and res extensa and res potentia. Now, on the other hand, Wolfgang Smith and others have said that this just fits into total Aristotelian-Thomistic view of what reality is all about, metaphysics. There are two kinds of reality, according to Wolfgang Smith. There are corporeal objects which can be perceived, and physical objects which can only be observed indirectly through instruments, i.e. by experimental physicists. And he says that every corporeal object X is associated with a physical object Sx, from which it derives all its quantitative attributes. So that measurement is what you do to get a ontological, i.e. a being transition from physical to the corporeal domain. And there can be no Schrodinger's cats because corporeal objects are not superposed. So there is this intermediate level of existence which applies to these macroscopic part systems, and it is this intermediate domain below the corporeal that I term the physical universe. And he says that Thomism can explain the difference between a corporeal object and a physical object. And he goes back to, again, talking about the difference between potency and act for a substance. A seed is a tree in potency, and a tree is a tree in act, okay? And you define form as an act, the capacity for being, and most important, what is substantial form. Thus, any substance has two aspects. Its matter, that is the lumpy stuff that it's made of, and its form, its whatness. And finally, here's where St. Thomas comes in. The act of being is the most intimate element of anything and the most profound element in all things, because it is like a form in that it to all that is in the things. And this is what he means by substantial form. And I'm sort of fuzzy about this, and if people want to explain it better than I can, I would be most grateful. Fourth, the substantial form is what distinguishes a corporeal object X from its counterpart, physical object S, Sx. Okay, So then finally, what presents itself to the eye as an aggregate of quantum particles, say like the ice cube, is in fact a corporeal object. They no longer exist really as separate molecules in ice. They are no longer physical and can no longer, strictly speaking, be considered as particles. They participate in the being of that entity in its substantial form. Since physical particles lack essence, they lack being. And I'm going to say a little bit more about that later because it's something I don't understand. Then, because of this, you no longer have to worry about quantum superposition. There are no Schrödinger cats. And you represent microscopic physical objects as systems defined by observables that will be measured by some instrument. And you have your ordinary or quantum restrictions related to the Heisenberg uncertainty principle. And again, I take the water as a collection of, represented as a collection of molecules. And we saw that. Now, here's one very important notion introduced by Wolfgang Smith. What is measurement? And his idea of measurement is that it is an act of vertical causation. What is vertical causation? It is causation outside of time. In other words, as represented by the diagram on the right, the universe is a circle in time, but God is timeless. He's at the center of this circle. He sees the whole circle. And the little arrow he's drawing from God's head to some act is the act of measurement. So God is creating the universe in every single act of measurement. Not only the act at the beginning of the universe, the Big Bang, but any particular act of measurement that converts a potentia to an actus. And that is really a remarkable notion. Okay, so that's my summary of what Wolfgang Smith is, and I have some final thoughts, questions to be answered. First of all, does this introduction of metaphysical, of Aristotelian and Thomistic concepts, does it explain the quantum mysteries? And do you need the whole framework of Aristotelian Thomistic metaphysical concepts? Or can you just, as KKE did, use the ideas of potentia and actus by themselves? And what about Wolfgang Smith's new ontology? Are there some propositions that I wouldn't say difficult to accept, but possibly difficult to understand? I have been active in MRI physics after my academic career, and I'm showing you an MRI image of the head. And what this image shows are water protons that are acting as quantum objects in a magnetic resonance measurements. They are different according to their environment. The protons in fat will interact differently and come into resonance at different magnetic fields than the protons in water, or the protons in healthy brain tissue, or the protons in tumor. So I don't understand if these are part of subsumed by a whole system and don't act individually, how you can get this experiment going. That's my question. Finally, I'm going to give you some references. They're listed here. I'm going to particularly recommend Robert Kuhn's as being an exhaustive and several new ideas, thermal substances. I don't understand everything he's written, and I have to go over it again. But Greg Jaeger and Gil Sanders give very nice, clear explanations of how quantum theory can be put into this Aristotelian Thomistic framework. And with that, I'll pass and try and answer questions that you might have.
Okay, well, thank you very much. So, very interesting presentation indeed. So now for our next activity, we call it the Q&A session, and we'll be listening to your questions being held and carried out. Now, our question and answer moderator is going to be Sheila Roth, who is ITEST Administrative Assistant and board member. So with that, I want to let Sheila take over.
All right. Thanks so much, Tom, and to our presenters. We have several questions. The first question is to Sebastian Mahfood, Dr. Mahfood from Matthew. He says, if there are three levels of abstraction, why then not also distinguish soul and spirit so that man is a Trinitarian being and not a dualistic one?
Well, thank you for that question, Matthias. I've responded to some of these questions in the chat room simply to encourage conversation among the participants. And in the encouragement of that conversation, interaction. So I'll read what I posted back to Matthias. Aristotle defines human persons as individual substances of a rational nature, so hylomorphic, as material and spiritual beings. The soul he describes as the form of the body, and we would extend this definition to how St. Thomas provides the fullness of what Aristotle is talking about in light of our faith tradition. So it wouldn't be wrong to make a distinction between the soul and the spirit in relation to physical body the soul forms. But how would you make the distinction between the soul and the spirit as unique non-material phenomena? That's a question I have. Once you make the distinction, you could say that you've shifted from a dualistic being to a Trinitarian one. And that may have already been done in some philosophical or theological anthropology. And then I provide a couple of useful courses. The CatholicThinkers.org has posted all of the International Catholic University courses that Ralph McInerney put together. There's 44 of them. And they've posted most, if not all at this point, of those courses for free on CatholicThinkers.org. So two of them I would suggest as useful viewing are Thomas Hibbs' Philosophy of Human Nature and Father Brian Milady's Nature and Grace, which are philosophical and theological anthropology, respectively. But that was quite a thread of conversation on the chat in the chat room.
Oh, he said, "It seems my microphone is not working." I think Sebastian's answer is very interesting. He says.
I look forward to learning more about this from Matthias at the December webinar. So for those of you who are interested in this topic, please come to the December webinar to hear Matthias's talk, and also come to the October webinar where we will have Terence Lagerland presenting. So we have a whole second half of this year devoted to physics and to the nature of such things. So, thank you, Sheila.
Okay, thanks. Speaking of Terence Lagerland, he has a question for Dr. Kurland. Would you agree that Kastner, Kaufman, and Epperson have a simpler understanding of the difference between, I'm going to try pronouncing this, res potentia and res extensa, and how observation transforms the first into the second category than Wolfgang Smith's conception of the difference between physical and corporeal objects? I think they're both getting at the same reality, but I can understand KKE's concept much more easily.
Yeah, thanks for the question. I agree. And the thing is that what you have to ask yourself is, if you have this notion of res potentia and res extensa, are those sort of arbitrary, picked out of the blue to just apply to this? And how do they fit into a general picture of the universe? So that are they ad hoc, in other words? And if they're ad hoc, then maybe they're not so great as something which would have a general system. My own opinion is that the one who has explained it best in all sorts of ways, including the idea of the microscopic objects being embedded in real material macroscopic objects is Robert Kuhn's and his idea of thermal substances. And I would have talked about that, but I don't totally understand it, so I couldn't really talk about it very well. And also it would have made this go on till about supper time, I think, if I were to try and go into it at any length. So, but I recommend his articles given as reference, and I think that so far to me is the clearest, or perhaps I should say the most definitive attempt to put this into a, how shall I say, universal metaphysical framework. Did I confuse you enough with my metaphysics with a physics accent?
Very good. Matt C. has a question for Dr. Kurland. He said, you explained how Aristotelian-Thomistic metaphysics can provide some form of answer to superposition. How does it explain entanglement?
Well, the KKE just say that it removes it. In Wolfgang Smith's scheme, I would imagine that the act of measurement, which is what removes the picks out the object that is measured. So again, it's this idea of vertical causation. In other words, that transcends space-time reality. Space-time reality, space-time, and I didn't really say enough about this in Wolfgang Smith's ontology, is not part of the physical, is a separate thing. It is not necessarily part of what totally constitutes reality. So that this explains the fact that entangled objects are not really part of space-time. They are linked together, but they're linked together in a framework that doesn't have space-time context or environment. Does that answer your question? That's my understanding.
Okay. Okay. Great. I have a question from Mike Oslantz. The Catholic understanding is predetermined by their dogmatic definition of heaven and eternal life. Neither of these two concepts possess scientific validity, do they? Don't remember what he's referring to there. Sebastian, do you?
What I believe Mike's calling into question is the Catholic understanding as empirically verifiable. So I pointed out that this is a great moment of surprise experienced by students of philosophy in college seminary when they graduate into Theology 1. In philosophical studies, the greatest argument is demonstration, and the weakest is authority. Aristotle wouldn't say this is true because I said so. Aristotle would say this is true because I can demonstrate it. So, but he's not demonstrating it empirically through experimentation. Aristotle was a qualitative, not quantitative kind of thinker. So you get to theological studies. The students have studied this philosophy. Demonstration is the greatest form of a proof of argument, and authority is the weakest. Then they jump into theology, and Theology 1 says, no, authority is the greatest argument. Authority, namely that of Jesus Christ. So it's not possible to measure metaphysical realities using empirical methods. And that's what's required, or what's required is philosophy, and in order to understand metaphysical realities. And the philosophy used in Catholic teaching is the perennial philosophy of Aristotle and St. Thomas. That is moderate realism. So Enlightenment philosophies have their foundation in doubt. So that's why our Catholic faith doesn't really ground itself in the Enlightenment philosophies, though there are those who would disagree, namely the Transcendental Thomists. So what we study in classical philosophy up to the present day is this dynamic tension between Platonic idealism and Aristotelian realism. So none of that can be empirically verifiable. And to Mike's point then, if the only thing that we can ascertain is true is that which can be empirically verified, that which can be measured by our senses or by our instruments, then we're limiting ourselves to materialism. And we, as hylomorphic creatures, understand that there's more to us than what is material. The concept of love, for instance, is not. There's no way to measure it through empirical means. So that may answer. So I know that Mike has a response. Mike, do you want to turn on your microphone and respond?
So Sebastian and I have met many times, discussed many things, just to let the rest of you know. I would just say this, Galileo, Darwin, the whole thing about Big Bang are perfect examples of how theology continually resisted what science was saying, and theology only came around finally because of overwhelming evidence and people believing. So all I'm saying is that science needs to be much more in the debate, and the bigger picture, and Sebastian and I have had many discussions about this as well, is, and I'm glad the word Jesus finally came up in our discussion here, is that the context of anything that we should be talking about needs to be focused on what Jesus, the message and mission of Jesus. And I think that at the end of the day, when we talk about verifying things through three independent sources, that's what creates the real basis of faith and turns people's hearts as well as their minds into coming closer to God. So I feel like in my discussions, I just keep raising those questions. So I hope those comments are helpful in some way. Thank you, Mike.
Can I come in there?
Sure, please.
Yeah, I think there's a lot of misunderstanding about the term the Big Bang. A lot of Christians I speak to say, "Oh, surely the Big Bang didn't create the universe." They actually think the term means a Big Bang created the universe, but it doesn't. To quote J.P. Moreland, a Big Banger set off the Big Bang, and the Big Banger was God. And if you look to Genesis, the opening lines, "in the beginning," actually proves a big event bang. Another thing too is there was no bang. That's a metaphorical term. Probably wasn't big. It would be smaller than a period point on a paper, but became expansive and big. And the second law of thermodynamics tells us the universe is expanding just right on in sympathy with the Big Bang, or a Big Bang. So the Big Bang didn't create the universe.
Can I respond to that just quickly?
Sure.
Never said that, or didn't mean to imply that. What I meant to imply is that the literal definition of day one, day two, day three creation was being held rigidly. And the Big Bang, and my own personal feeling is, yes, the transcendent God, definitely some transcendent force, whether, it was God or whoever, depending on your religious outlook. Yeah. But yeah, the Big Bang didn't just happen by itself. So I don't want to imply that. But
I'm not suggesting you said that. I understand you're right. But a lot of Christians do think that it defines some kind of strange event called the Big Bang. But yeah, I know. One more thing about science and theology is that the opening lines of St. John's Gospel, to me, is the most profound statement in the history of humankind. In the beginning was the Word obviously meaning logos in Greek. Nothing can be more profound than that, because everything that tries to explain something profound has to use logos in order to explain it. So it precedes everything. It even precedes love. So if people think that love is the core of Christianity, it's actually logos, because in the beginning was the logos. And again, in terms of science, in order to apply science, one has to use logic, logos. So therefore, and you mentioned as well about scientific or empiricism. A few other things are aesthetic values and judgments. You can't use empiricism for that. Or things like the existence of other minds, the reality of the external world, all these things, empiricism really wouldn't work.
I couldn't agree with you more on that. In fact, some of my writings that I'm putting together are totally based on the logos and
Right.
And that. So a totally agreement with you there.
Yeah, that's great.
Okay. We do have some other questions. Kevin Powell asked something. He has taken or read 2 great courses or Wondrium courses, 24 half-hour lectures each, and it's given him some familiarity with quantum mechanics, but not understanding per Feynman. Is there a good course linking quantum mechanics to Thomistic thought? I'm going to need many more hours to grasp this. I agree with you, Kevin.
Who is that question directed to?
Well, Bob, I think you could take that one. You're developing just such a course right now, I believe.
Yeah, I'm trying to, I think what I'm going to do is to, first of all, going to revise my ebook because all this stuff isn't included in it. And then I'm going to try to do a online course, which at the age of 94 is a little bit tricky, but we'll see how it can go. But the thing is that I think you have to be predisposed to put this physics into a context in which it is into a philosophical or metaphysical context. And if you're not predisposed to do this, and many physicists, many scientists aren't so disposed, it works. Why worry about, why it works? This is an instrumentalist view. But if we are human and we want to know and understand things, then we want to see things as part of a bigger picture. And this bigger picture does include how God works. And part of that is explained by the 2 geniuses of long ago, Aristotle and Aquinas. So to link that up, I know there is a Dominican who's doing this with the theory of general relativity. And I'm not quite sure how that's going on, but I've read the title of some of his articles. So, if we believe that God arranged things as Ken Francis so aptly put it, and according to the first line in the Gospel of John, Logos, then that Logos is the thing that we're trying to understand. But the final thing I think that one should understand is that things may not be, God is a mystery. God is the final mystery. We cannot hope to, I forget, maybe it was Augustine who said that if we think we totally understand God, then it isn't God. So, God is, total understanding of God is beyond us. So we're trying to explain as much as we can of the world about us by rational, empirical means. And, we're limited. And that's, I think, the final answer.
If I could recommend a writer, obviously Sebastian would be fantastic to look up as well. But you're probably familiar with the work of Ed Feser. He's a Christian writer.
He pronounces it Feser. Ed Feser.
Ed Feser. And a lot of his work is online for free. If you go to his website, and he's got tons of essays and stuff on Aquinas and what we just discussed there. So just to recommend him, he's a very interesting philosopher.
Okay, good recommendation.
Yes.
We have
Feser.
Ed Feser. I think it's Feser.
Yeah.
Question from Terence Legerlund, and this is for Dr. Kurland. My reading of several recent papers about quantum measurements is that one of the 3 cherished concepts that follow must be incorrect. 1, there is a physical reality independent of the observer. 2, experimenters can change measurement parameters or settings freely, no superdeterminism. 3, locality that is no faster than light speed information transfer. Experiments with entanglement clearly show that one of these is incorrect. There are various opinions about which of the three is incorrect. Dr. Kurland, would you agree that as theists, we should insist upon the first and second as being true, and therefore locality must be violated?
Okay, this old guy needs repetition. I have a short-term memory gap. Can you say them again, please? Or
yeah, let me say it again. Hang on. One, there is a physical reality independent of the observer. Two, experimenters can change measurement parameters or settings freely. No superdeterminism. Three, locality that is no faster than light speed information transfer.
I think, I would say, here's my view. I agree that I think and I'm not sure this matches all three alternatives, but that there is a reality that transcends space-time, and this I agree with Wolfgang Smith, and that this explains the entanglement phenomena. So I'm not sure how that fits among the three alternatives. I guess it's the third one, probably, that the faster than light thing is not valid. But see, these aren't real quantities, so they're not real until the entanglement. They aren't real quantities. They don't exist in the world as we know it until they're actually measured. And then they become from res potentia to res extensa. So that part of the KKE theory seems to be a way of explaining it fairly clearly.
Sheila, do you want to bring Terence on to respond?
Sure. Yeah, I'm going to look for him here. Terence, do you want to unmute and respond to that?
Hello, can you hear me?
Yes, we can.
Okay, yeah, so basically the papers that I'm talking about are experiments with entangled particles, and they bring up the fact that both theoretical calculations similar to the Bell can be done, and experiments can verify that one of those three postulates have to be wrong. And so it seems to me that the non-locality, in other words, spooky action at a distance, as Einstein called it, is the one that must be wrong. Some have suggested that reality independent of an observer is what's wrong. In other words, that there is no actual reality. Everything is relative to who observes it. But I don't think that's the case. And my idea is that non-locality can exist not only in space, but also in time. In other words, knowledge of the future would be something that would be non-local in the relativistic sense. And by postulating, as Wolfgang Smith does, that God is the one who determines finally that transition from res potentia to res extensa, and using the fact that God is outside of time and therefore knows the future, that could be the non-locality that comes in these entanglement experiments, because he knows what settings the experimenter is going to use when he does the experiment long after the entangled particles were created in the entangled state. And therefore, he can arrange that there be a reality, a fixed reality independent of the observer, and yet allow the free will of the experimenters or the observers. I don't know what you think about that idea, but that's kind of my idea.
It's interesting. There is an interpretation of quantum mechanics called the, another senior moment, interactive theory, in which photons are transmitted. Let's see, and I'm trying to remember the name of the physicist. He's a guy in Washington State. But at any rate, that photons go forward in time as well. In other words, that both time both types of time in the solutions of Maxwell's equations are valid, so that you get photons going forward in time and interacting as well as backward. What is that called? Oh, well, I'll remember and then modify it and put it in the chat. But, so that this is something, I think, like what you were talking about, but that there is a reality independent of space and time, or a level or a domain of reality independent of space and time. And I think that's a good way of looking at it. This is what Wolfgang Smith proposed.
We have somebody here, another physicist who made a similar observation in his book Everywhen, God, Symmetry, and Time. And I posted the link to that book here in the chat. Tom, would you like to add anything to this conversation?
No, I'm really enjoying it quite a bit. The thoughts about being considered today are kind of different from mine, and I'm finding it very interesting. I can't say I have a particular thought here or there to add to it, but I'm paying close attention.
Another question, this will be for Ken. Is there a connection between quantum theory and panpsychism?
There possibly could be. Again, it's what I mentioned earlier, the fact that if everything in the universe is conscious, then those particular weird little things in the world of quantum mechanics would also be conscious. And what they would be conscious of, or how they would think, if I can phrase it that way, is quite bizarre. I'm only glad I'm not getting the questions that Dr. Kurland has been answering. I've never in my life heard such complex questions and getting great answers back from them. So that's what I have to say to that.
Well, just wait until Ken, we get artificial intelligence in your coffee pot or in your coffee.
Okay, another question. This is for any of the speakers. Why should it be necessary that an Aristotelian-Thomistic interpretation or any interpretation be required for quantum theory? It works. So what else is needed?
Does anyone want to take that? I would simply say that our philosophical point of view, our theory of knowledge, our epistemological foundations require some worldview or some window through which to explore the world. And that has to be a window that is greater than the material reductivism, because scientific theories are wonderful in and of themselves, but they change all the time. Is there a constant to which we can refer that says, okay, well, we do have a metaphysical understanding, and so if the atom doesn't look like the model that was represented, or if we see that a picture of the galaxy and suddenly come to the realization that, wait, this is also a model because we don't yet have a satellite out at the edge of the galaxy sufficient to take a picture of the whole thing and send it back to us. Once our scientific experiments reveal something different, then we may find ourselves to be, in unstable ground. But a philosophical foundation is much more stable and provides us with a more coherent and consistent worldview. Bob, you had something on that?
Yeah, I alluded to it earlier, I think. The view, the so-called instrumentalist view that, if it works, don't worry about why it works, is held by a lot. This was the way I held for 20 or 30 years, and doing things that involve quantum mechanics and getting good grades in courses on quantum mechanics. And I thought I understood it, and I was a fool. I wasn't a liar. But at any rate, that I think the thing is that if you have that view, then it's your choice of the way you want to think about the world. It's like being a Christian or not Christian, believing in God. There are some things that go beyond rational modes of choice. There's a temperament involved. So that if you think about no need for quantum mechanics, that's a legitimate way for somebody to act. But it is not satisfactory for a lot of people, including myself, who want to see the universe as a complete creation by God and to try to understand it as such. In other words, what Ken Francis was saying, to try and understand the logos as much as we can.
Right, and the fields don't necessarily conflict with one another. Science really answers how questions. Philosophy answers why questions, and theology answers who questions. So it's very possible to have one's metaphysics, as I pointed out earlier, you have different metaphysical assumptions and foundations for the different degrees of science that we have. But ultimately, we're all asking the same question, which is why. And then once we throw God into the mix, that why becomes a who. And the who question is the subject of theology. So when ITEST explores the theological encounter with science and technology, we're really exploring the relationship between the who and the how, between what God knows things as the cause and humans know things in their effects. Philosophy is helpful because it helps us hone in on the why questions. What are the causes, the formal, the material, the efficient, and the final of anything? So we have a greater richness. We get more. That's the answer. We get more if we engage it in this tripartite way: the how, the why, and the who.
We're going to do one last question, and then I'll send it back over to Tom. This is from Terence Legerland. He says, Bohm's theory, is that how you say it? B-O-H-M? His theory about superquantum fields being equivalent to mind seems like a kind of panpsychism, since superquantum fields belong to the realm of physical realities, objects, but Bohm is saying that they can be conscious like a mind. I don't agree with this concept because I don't see any evidence that physical systems can think or be conscious. Do you agree with that, Ken?
For a start, I don't agree at all with panpsychism. I think panpsychism is just the last grasp at something to explain consciousness and things like that. So I would just rule out panpsychism altogether as a complete no-no. I know you could argue if you're an instrumentalist, as was mentioned. That's a very interesting term, instrumentalist, because it's like you live your life whereby you just, on a practical level, believe in certain things, but never fully sure. So the pencil or the cup or the chair might be conscious, but it's not going to ruin your day. Your mind won't be occupied by it because it's not practical. But I would rule it out. The panpsychism, it's a little silly as well, I think. I know you could argue that certitude is impossible, and that is a self-refuting statement in itself because you're actually being certain of a statement. So, that's where I would see that.
It's fun in fantasy and in, where, Douglas Adams' Hitchhiker's Guide to the Galaxy, you've got a plant that's conscious as it's falling from the sky and crashes on the ground. Or in horror, where you've got Christine, the car, in Stephen King's book that's conscious, or even the Overlook Hotel that's conscious. It makes for great fantasy or science fiction or horror literature to have these kinds of thought experiments, to expand our imagination in those ways. But thought experiments. Bob?
Yeah, I remember now. I looked it up briefly on the web. It's the transactional interpretation of quantum mechanics that has photons going into the future.
Okay. Well, I think that's going to wrap up our Q&A. I'm going to bring Tom back in and to close up the webinar.
Okay, well, thank you very much, everyone. I'm glad you all had a good chance to learn a lot about this. I want to say thank you, certainly, on behalf of not only myself, but all the participants, to Dr. Sebastian Mahfood, Kenneth Francis, and Dr. Robert Kurland for their excellent presentations. And I also want to thank Father Michael Lampe and Sister Roseanne Ficker for leading us in prayer. So our concluding prayer is led by Sister Roseanne Ficker, who will offer this prayer for us. Sister Roseanne has been a school sister of Notre Dame for 63 years and currently serves in Hispanic ministry for the Archdiocese of St. Louis. Sister Roseanne.
Dear God, you are all-loving, all-knowing, all-powerful. We thank you for this great opportunity to hear from these scientists who understand much more than most of us do. We know that we are limited. Dear God, you are not. Help us to live in mystery. Glory to you, source of all being, eternal word, Logos, and Holy Spirit. Amen.
Hello, God's beloved. I'm Annabelle Mosley, author, professor of theology, and host of Then Sings My Soul and Destination Sainthood on WCAT Radio. I invite you to listen in and find inspiration along this sacred journey we're traveling together to make our lives a masterpiece and, with God's grace, become saints. Join me, Annabelle Mosley, for Then Sings My Soul and Destination Sainthood on WCAT Radio. God bless you. Remember, you're never alone. God is always with you.
Thank you for listening to a production of WCAT Radio. Please join us in our mission of evangelization. And don't forget, love lifts up when knowledge takes flight.